This video is going to review some natural log and exponential properties that might show up in doing the calculus that involves them. So it's not intended to teach you all of this, it's just a refresher. So first, a natural log function that is abbreviated as ln, so that's ln of x. And my exponential function is e to the x, and e is called Euler's number, and it's an irrational number like pi. It's like 2.71 something. And what's important to know is that they are inverses of one another. And what that means is if I take a number, say x, and I raise e to that power and get that answer, and then do the natural log, I'm going to be right back where I started. So I'm going to end up at x just as I started with that x. And it works if I have e raised to a natural log as well. So because my e and my ln are inverses of one another, if I natural log some input x and then I exponentiate it, if I take e to that, it's just going to cancel out. So the e and the ln cancel out, and I end up with this x, which is right back where I started. So I started with an x and I ended up with an x. So just think about this exponential and this natural log is canceling each other out, just like addition or subtraction, multiplication, division, natural logging and exponentiating, they wipe each other out. So that's useful to know on a question like number 1. And I know that this natural log and this e are going to cancel each other out, and it just leaves 7 as my answer. So my answer here is just 7. And that's the most basic type of using that property. On number 2, so the first thing I need to do is to rewrite this radical with an exponent. And that just goes power over root. So it's my second power and a cube root. And I can't use that inverse property until I have this e written in the numerator. So I'm going to move it up there and stick a negative on my 2/3 power. And once I do that, if I natural log e to the negative 2/3, my answer will just be negative 2/3. And these can go the other way around too. So in question number 3, again, if you just have an e and a natural log, they're going to cancel each other out, and my answer will just be 7 on this one. And number 4 takes a little more because I need this just to say a natural log of something. So now that's where these log properties come in that I have written up here. And just a reminder, I'm going to use this power property over here. And what this says is if I'm multiplying by a number out in front of my log, that number becomes the exponent of the argument. So I can just shift that from multiplying out in front to becoming the exponent. So that's what I'm going to apply in number 4. So that 2 that I'm multiplying out in front is going to become the exponent of the 7. And now this is going to work exactly like number 3 worked. So if I have e raised to the ln of 49, my answer will just be 49. Our next question is going to focus more on these properties. So I'm going to use that one that I just did. So first of all, my directions want me to write this as a single log expression. So on this one, how I have ln written twice, I want to just write it one time. So I'm going to apply that property that I just did that says any number that's being multiplied out in front will become the exponent of that argument. And then I'm just going to simplify these just a little bit. So I'm going to call this 25. And this just means the square root of 81, which is a 9. And I've gotten this a little bit closer to my goal of writing as a single log expression. But I still have 2 natural logs written right here. So just recall that property we set up here, that if you are subtracting 2 logs, so here if I'm subtracting 2 log expressions, I can combine them as a single by dividing those 2 arguments. So when I have a subtraction, I combine them together with division. So back to this one. If I want to rewrite this as a single log expression, I'm going to take my 25 and my 9, and I'm going to divide them. And that gives me my answer of natural log of 25 over 9. And sometimes when you do these things, they just feel so random. So I pulled up a calculator screen here. So you could see that when I take my original problem, this 2 natural log 5 minus 1/2 ln 81, I get my answer of 1.02165. And when I do the natural log of 25 over 9 over here in the calculator, you can see that you truly do get the same thing. So there's no magic involved. These properties are valid, and they truly do give us two equivalent expressions. The next question will be using these properties as well. So I'm going to use that same one that I did before, that power property that says any number that is multiplied out in front will become an exponent. And that 1/3 power just means to do the cube root of 27, which is 3. And if I have a natural log of 3 plus another natural log of 3, I now have 2 of them. And applying that power property brings the 2 to the exponent position on the 3. So I'm going to put it up there. And I can see this becomes the natural log of 9. And that would be my answer. I'm going to look at this another way, starting at this step right here, that's going to hit another one of these properties. So another one of these properties say that when you are adding two logs together, provided they have the same base, I'm just going to take these arguments, the numbers I'm taking the log of, and multiply them together to combine to a single log statement. So I could apply that at this moment on question number 6 here. So if I take natural log of 3 plus natural log of 3, since they are both natural logs, I can just multiply my 3 times 3, and I could arrive at that natural log of 9 that way as well. So the way that you do it doesn't really matter. You can see we ended up with the same answer either way. I just wanted to hit as many properties as I could. And my last example is going to show you what to do if you're asked to combine these, but one of your terms does not have a natural log in it. So this is just a straight up 9. So I'm going to apply that power property first, just like I did in the previous ones. So now what I'm going to do is force this 9 into a natural log expression. I'm going to do it by what we had said up here about that inverse relationship. So I'm going to focus on what this one says right here. So I'm actually going to be working it backwards. So if I had a 9 right here where the x is, I'm going to work it backwards and call it natural log of e to the 9th power. So back down here, I'm going to call that 9. I'm going to write natural log of e to the 9th power. And now that I have these written as logs of the same base, to perform the subtraction, I take my 36 and my e to the 9th power and I divide them. And I've accomplished what the question asked, which is just to rewrite this as a single log expression. And like I said in the beginning, this wasn't intended to teach you how to do logarithms and exponentials. It was just a refresher of some items that might come up as you do the calculus with these.